Very good morning, students. I hope that you all are fine at your place. So today, beta, we are going to start your new chapter, that is chapter number 5, and the name of the chapter is heat. So the very first topic from your book is heat is a form of energy. So first of all, beta, I want to give you some examples through which you can summarize that what is heat. In winter, what we do? We sit in the sun or near the heater to feel the warmth of the sun and heater. The reason is this, that we receive the heat from the sun or the heater, which we can only feel but we can't see that. So thus heat is the form of energy which we can feel but we can't see. Got it, beta? Then next we can say that sun is the vast source of heat energy. Sun always provide you heat as well as light energy. So sun is the vast source of heat energy. The heat energy of the sun makes water to become warm and evaporate from the ponds and lakes as water vapors and form clouds. So this sunlight is also helpful to the plants to prepare their food by the process of photosynthesis. In your day-to-day life, you might have seen that when you rub your hands, so there is a heat produced because of that rubbing. On burning coal or cooking gas, heat is produced because many physical as well as chemical changes take place there. So we are coming to our topic, what is heat? Heat is a form of energy flowing from one body of matter to another spontaneously due to their temperature difference. So temperature difference means the both bodies are not at same temperature. So here you can see characteristic of heat. Heat always transfers from a body of higher temperature to a body of lower temperature, or heat flows spontaneously from a hotter body to a cooler body. So here you can see that we have taken an example. This is the hotter side of this and this is the cooler side. So how the heat will flow? Heat will always flows from hot body to the cool body. Got it? Until and unless the temperature becomes same. Getting better? Heat will always flow from a body which is hot to a body which is cold when they are kept in contact. Next is hot and cold. What are hot and cold objects? In our daily life, we come across a number of objects. Some of them are hot and some of them are cold. For example, tea is hot and ice is cold. So how you get to know whether a body is hot or cold? Because of the heat received by them, you will be able to tell whether this body is hot or cold. Some objects are hotter than others and some are colder than others. We often decide which object is hotter than the other by touching the objects, but we can't rely on a sense of touch to decide how hot or how cold an object is. Can you exactly define that how much this body is having the temperature by touching it or by seeing it? No, we can't, because our senses of touch and sight are not reliable. We can't rely on them. Thus the hotness of an object is measured by its temperature. So here comes new term, that is temperature after heat. When we add heat to the body, the motion of its particle increases. That is, the kinetic energy of that particle increases. And when we remove heat from the body, the motion of its particle decreases. When we add heat to the body, the temperature rises. And when we take out the heat, then the temperature falls. In other words, you can say that when a body is heated, its temperature rises, and when a body is cooled, its temperature falls. Is it clear, beta? Next, the term is temperature. Temperature is the measure of the degree of hotness or coldness of an object. So here you can see this is a quantity which tells us how hot or how cold a body or a thing is. Next are the units of heat and temperature. Beta, the SI unit of heat is joule, whose symbol is capital J. And the other two units are calorie, which is denoted by CAL, cal, and kilocalorie, that is K, cal. And there are relations between these three units. 1 kilocalorie equals to 1000 calorie, 1 calorie is equals to 4.2 joule, and 1 joule equals to 0.24 calorie. Got it, beta? Next, how we can define 1 calorie? 1 calorie is defined as the heat energy required to raise the temperature of 1 gram of water by 1 degree Celsius. So when we want to raise the temperature of 1 gram of water by 1 degree Celsius, that heat energy required will be defined as 1 calorie. Next is 1 kilocalorie. It is defined as the heat energy required to raise the temperature of 1 kg of water by 1 degree Celsius. Got it, beta? So both are the heat energies only. The difference is calorie will raise the temperature of 1 gram of water by 1 degree Celsius, whereas kilocalorie will be the heat energy required to raise the temperature of 1 kilogram. Only difference is 1 gram and 1 kilogram of water by 1 degree Celsius. Next is the units of temperature. The SI unit of temperature is Kelvin, and other two units are Celsius, degree Celsius and degree Fahrenheit. This thing you have to note that for unit Kelvin, the SI unit Kelvin, we don't write degree Kelvin, we simply write K. Got it? This thing you have to keep in mind. With Celsius and Fahrenheit you use degree, but with Kelvin you will not. Next, the device to measure the temperature is known as thermometer. Thermometer measures the temperature of a body. We are having two kinds of thermometers, clinical thermometer and laboratory thermometer. So clinical thermometer is used by the doctors to measure the temperature of patient. Got it? Next is laboratory thermometer. Laboratory thermometer, beta, we use that in our practical labs to measure the temperature of certain liquids or chemicals. So it is having a long narrow glass tube. It is having bulb at one end containing mercury. It has a scale marked in degree Celsius, and the range of the laboratory thermometer is minus 10 degree Celsius to 110 degree Celsius. Now comes that how we can measure the temperature of a body by using laboratory thermometer. So beta, here you can see that we have taken water. This is your activity 2, and we have to measure the temperature of water. So what we will do, we will dip the thermometer in the water so that the bulb of the thermometer does not touch the bottom or the sides of the beaker. Then we have to hold the thermometer vertically such that the mercury level will rise, and we will wait so that it becomes stable, and after some time when it is stable we will note the level of mercury and we will take the reading. That will be the temperature of the water. Got it, beta? How we will do? We will just dip the thermometer in the water or the liquid whose temperature we want to measure, then we will allow the mercury to rise till a stage when it will get stable. When it will stop rising, then we will note that reading, and that reading will be the temperature of water or the liquid which we are measuring. Okay beta? Next is how we can measure the temperature. There are 3 scales of measurement: Celsius scales, Fahrenheit scale and Kelvin scale. On Celsius scale, the freezing point of water is 0 degree, whereas its boiling point is 100 degree Celsius. So this scale is calibrated from 0 degree Celsius to 100 degree Celsius. Next is your Fahrenheit scale. The freezing point of water is 32 degree Fahrenheit, whereas its boiling point is 212 degree Fahrenheit. So this scale is calibrated from 32 degree Fahrenheit to 212 degree Fahrenheit. Here you can see that formulas are given for conversion of Celsius scale into Fahrenheit scale. These are the simplified form. If you want to use these, you can use. Otherwise, if you want to do in elaborated manner, then you can write from the book. It's your wish which formula you want to use. Both are correct. This is the simplified form. Got it? So degree Fahrenheit equals to degree Celsius into 9 by 5 plus 32, and degree Celsius is equals to degree Fahrenheit minus 32 into 5 by 9. And how we can convert Celsius scale into Kelvin? It will be degree Kelvin is equals to degree Celsius plus 273. Got it beta? These formulas you have to learn. You can learn from here or you can learn from your book. It's one and same thing. Next beta, these things you have to remember that the Celsius scale was introduced by a Swedish astronomer whose name was Celsius, and this scale is named after him. Fahrenheit scale was introduced by the scientist Fahrenheit. Kelvin scale was introduced by the scientist Kelvin. So here you can see this simplified table. Here from here you can remember the scale is Celsius. It is denoted by degree C. Ice point is 0. Steam point is 100. And how many divisions between ice point and steam point? They are 100. Got it? Steam point is the upper fixed point and the ice point is the lower fixed point. Then for the Fahrenheit scale, ice point is 32, steam point is 212 and number of divisions are 180. In Kelvin, the ice point is 273, steam point is 373 and the number of divisions are 100. So from here you can see that the number of division between the Celsius scale and the Kelvin scale, they are same, but it is different from the Fahrenheit scale. Got it beta? Next we are having this diagram. They have represented you 3 scales of temperature: Celsius scale, Fahrenheit scale and Kelvin scale. These are the ice point, these are the steam points and these are the number of divisions. I think we have discussed it now only, so there is no need to discuss again. Next are the examples beta, that we have done the relations to convert, and the very first example is to convert 0 degree Celsius into degree Fahrenheit. In relation, this is also the relation C by 5 equals to F minus 32 by 9. So in place of C you will write 0 because we are given 0 degree Celsius and we will solve for F. So 0 upon 5 equals to F minus 32 by 9. After solving it, we will be getting F equals to 32. So 0 degree Celsius is equals to 32 degree Fahrenheit. Is it clear? Next we are having to convert 100 degree Celsius into degree Fahrenheit. So in place of C we have to write 100 and we have to solve for F. Got it beta? After solving we will be getting 212. Next is to convert normal human body temperature 98.6 degree Fahrenheit into degree Celsius. So from here I must include that the normal body temperature in degree Celsius is 37 degrees Celsius and in Fahrenheit scale it is 98.6 degree Fahrenheit. So with this relation here you will write the value of F and you will solve for C. So C by 5 equals to 98.6 minus 32 by 9. After solving we get C equals to 37 degree Celsius. Next convert the temperature of water at 30 degree Celsius to degree Fahrenheit. So now here we will put the value of C and we will solve for F and we get the answer 86 degree Fahrenheit. Thus 30 degree Celsius is equals to 86 degree Fahrenheit. So I think this is clear to you. If any doubt is there, then you can ask in your WhatsApp group or in your Zoom class. Thank you. Have a good day.